Okay, so
Okay.
this is our cryopherous system. It's a sealed system.
Kind of hard to see in there, but there's
the two-stage turbine in there.
two-stage Tesla turbine in there, plastic rotors.
We've got this air inlet right here. This is actually compressed air, and the only reason we needed that was to kickstart the rotor because it was actually seized up in there. So that's what that is. This is our warm tank. Our water has been heated up to, but still below the boiling point of the water. It's been heated up so that we can run the turbine on the water, on the heat from the water.
It's got a little vacuum on there.
Yeah. So outside, this is our exhaust right here. It comes out of the turbine after it goes through the inlet, spirals around. It comes out of the turbine
and not connected directly to the turbine because the whole thing is encased.
This whole thing
so
is
it's
encased.
sucking on everything in the box.
Mm-hmm.
Yeah.
And then once we open up this valve right here to let the vapor pressure in, it starts to head towards the cold side, the cold tank. And the cold tank is the tank outside. That's where the water. With the ice pack. That's where the water condenses at. In the future, you don't actually need a cold tank because that's what the Tesla pump is for. The Tesla pump's to take out is to condense the moisture, or to draw the vacuum without having a condenser condense the moisture and draw that and continue holding that vacuum. So you don't need that temperature differential. You just need warm water or cold water eventually. When you get high enough vacuum, the cold water will boil. When you've got that, everybody talks about how the Tesla pump needs, how the Tesla pump is consuming energy. So how is it actually helping the system because it takes energy to rotate it? But actually, when you've completely evacuated a space inside of the Tesla pump, or nearly so, there's not actually much there. It's not actually passing volumes of air, creating work for the Tesla pump. It creates a little bit of work for the Tesla pump, but it adds an enormous amount of energy conversion capabilities to the actual turbine itself. Yes, this is our vacuum. This is our vacuum pump right now. We just got a little one. You'll need to charge the system once if you don't have any leaks in your conduits, and then it will continuously run until either your outside tank is warm or your inside tank is cool. So eventually you will cool down.
And this is just to suck the air out of the system, so you're pulling from the back end of the system.
Because the air clogs the whole effect of. If you got a bunch of air in there, that water, the air can't condense and maintain the vacuum. So yeah, it's just a clog in the system.
It had a 9-volt battery on it, consisting of 6 flashlight D
Okay.
So yeah, we've got this. There's 2,000 pounds of force pressing on this one. We're at full vacuum, which we actually haven't achieved. So there's a little bit less. It's probably like 1,600 pounds or 1,700 pounds. Total, that's about almost 12,000 pounds, less than 12,000 pounds, pressing on the outside because there's no ambient air inside pushing outward. So the water will actually, because this water is at a warmer temperature than the water outside, this water vaporizes, and once it cools down, once the water cools down, once you take the energy out of the water, it cool. And the reason it cools is because the heat energy is literally being changed into kinetic energy, and that kinetic energy transfers the energy through viscosity to the rotor. And the more energy that you extract, the more kinetic energy you give to that particle, the more energy you can extract from that particle, and the colder it will become. The more energy that you extract, because you extract the energy, it cools. It cools down. So in any system, or in at least this system, the efficiency of the system will be and how much energy we actually extracted will be determined by the pressure differential and the amount of actual water that you use during. So with a perfect Tesla turbine, if indeed Tesla is correct about 100% efficiency, you should get your water should come out frozen or at least very, very cold on this end, and it should go in warm. So you should be able to, theoretically, with enough vacuum, water can boil until it freezes. With enough vacuum on the system, by taking all the leaks out of the system, you could technically run on water that was below room temperature. But the main thing is because our tank is as the tank loses its heat energy, as it vaporizes, it's actually losing. It's dropping in temperature. It's dropping in temperature because that heat is being turned into kinetic energy and it's drawing that temperature away. So if you have a heat exchanger or if you have a radiator connected to your water tank and you circulate that water through the radiator, ambient air will actually continuously warm up the water and keep it from freezing. And that's where it's possible to get basically an infinite amount of heat energy, or to use an infinite amount of heat energy from ambient air in the system, because the water will vaporize and it will condense. Once you've taken all the energy out, it comes out cold, and because when it's cold, it condenses and no longer takes up all that space. It always stays empty. There's no pressure buildup in your cold side ever, unless your cold side heats up as well. But if you're taking 100% of your energy out of your cold side, out of your vapor, your warm vapor, then your cold side will never warm up because there's no heat left to make it warm. So it'll never vaporize in your cold side. So of course.
So you could have like a solar hot water tank with the
you just have a big old
solar
tank
up on your roof,
and surprisingly,
you'd always have heat there.
Yep, and average heat panels work at up to 90% efficient.
Well,
So
the evacuated tube ones are up to like 98, 99%.
Holy cow! Yeah. So technically, you can harvest 100% of the energy from like 1 square foot. What is it normally? It's basically 5 times the amount of solar density collection. You can collect 5 times more on average, because our best solar panels that we use today are like 20% efficient. Then you have to store it in the battery. The battery's not 100% efficient, so you actually end up losing more. And then of course your batteries will degrade after time. Actually, they degrade pretty quick. The ones that don't degrade quite as fast cost an enormous amount of money, and then once they finally do degrade, you're left with a big paperweight. Whereas with the water system, you would never end up with a big investment going down the toilet. And of course, the water storage is a lot cheaper for that reason, and because so you'll never run out, or you don't have to replace it every, say, 4 or 5, 6 years. You don't have to keep replacing that giant expense, but you can still store an enormous, many times more energy, because water is basically free. All you need is a container to put it in. So yeah, that's bare minimum capabilities of the system. Is the solar, which is just amazing.
So the pressure air got it unseized and got it spinning?
It did. It's looking a lot better now. Making a whistle because the oscillations in the air pressure, right? I touched it out would actually stop that whistle. Turn it in the right direction. Airflow. That's just air. I've heard the whistle before, but not like this. So this is something I've never seen before.
choke is one at the end.
Yeah. I'm gonna play around with that later.
What kind of bearings are in here right now?
They're ceramic bearings, but they do have a steel. I think it's a low-grade stainless steel. Shouldn't rust or anything like that, but I think, or my shaft is steel, so it did rust a little bit. Might be getting rust on the bearing, but see how this is slowing down. This wouldn't slow down if this was under vacuum. This would literally go and go and go and go and go and go. It's just full of atmospheric pressure. Atmospheric pressure has a lot of friction.
So the vacuum pump will suck all the air out, and then it should start by the pressure.
It should start by this
by the water expansion.
Yep. By the water expansion below water's boiling point. And
so we got to change the presentation name from the vacuum Tesla turbine to the Tesla steam engine.
the Tesla steam engine, the atmospheric steam engine.
That's really what it is.
Yeah.
Yeah. Yeah.
Well, utilizing water's phase change. But there's a lot more. We got 6 months. I'm gonna take that 6 months to prepare for getting the presentation down just right, getting the information out. Of course, we'll have drawings, we'll have diagrams, we'll have a full presentation, and we're gonna do a lot of work before the conference. We would like to build a metal turbine before the conference. We could use some help getting those resources to build it. If we can get this rotor balance, which is why we're working on the balancing patent, we don't want to have to send the rotor. We don't want to have to send the rotor out and have them balance it, and then have them send it back, and then maybe it's not balanced well enough. It's just a good thing when you're doing research too, to be able to do something your own. And of course, we're not going to get $60,000 for professional balancing machine, and Tesla's balancing apparatus works flawlessly. You just have to understand it, and we're starting to understand more and more about it right now. We're getting better with it. We've made some new discoveries. We'll actually have an update on that soon. That's actually right here.
So this is straight out of one of Tesla's patents?
This is straight out of his patents. One thing that Tesla did differently, he said you can put it in your casing, your turbine casing, run it in your turbine casing with the yieldably supported bearings, which actually you could keep in your, if you don't have to worry about belt torque or gears torque. We're going to put our generator directly on the shaft so that we don't have to. And the problem with putting the generator directly on your shaft normally is it moves at such an enormous velocity. The rotor, the generators aren't really designed to move that fast. Their efficiency goes down because the magnetic field inside of the iron cores that usually transfer the energy. Once it has to flip, because it's flipping magnetic field as it's running to and from the pickup coil, that iron core has to flip magnetic fields really fast. The faster it has to flip it, the more eddy currents you get in your iron, and the better materials it just makes it all more complicated. We're actually using the Newman motor concept. I gotta actually see if I can grab my rotor. These magnets right here.
But of course, those limitations for typical induction type generators, and there's Faraday homopolar generator and electrostatic rotary capacitor.
Oh, that's a little bit later down the road, but eventually we're most likely not going to need a generator. We're just starting with what we know. If we can draw it with electrostatic, which is what I really want to start experimenting with here. We need to get past that. We need to get past this part first, though.
So short term, this is going to be the generator.
This is going to be the generator short term. Yeah.
Rotating magnet.
And the interesting thing is these when you wrap two coils, this is diametrically magnetized. So one side over here is north, one side over here is south. I gotta put this other magnet down real quick. So, one side's north, one side's south. So if you wrap a coil around like this, one on each side of the shaft. And you rotate this, you can rotate it as fast as you want without any eddy current buildup. In fact, your frequency goes up as well, and a lot of the cooler experiments that you can do with generators and stuff, like say Tesla's hairpin circuit, run on higher frequencies. So it's just all around going to be no limit to the RPM, as long as it's balanced to that speed. The more speed you get, the faster your turbine goes, the more energy that you can extract and the less torque you need. That's the biggest misconception about torque. This is the biggest problem with the Tesla turbine is that people have is converting that high speed efficiently to get their torque to run their low speed generators. If they just started with a high speed generator to begin with, then they wouldn't need to convert it with belts or pulleys. Belts and pulleys at high speeds, they don't work. They don't like to work. They just build up a bunch of heat. I mean, I've done so many experiments in the past trying it that way, and that's how I realized, okay. And then of course I saw some older pictures and stuff of Tesla's apparatus, Tesla's turbines, and how he hooked up his generators, because Tesla did hook up his turbines to generators, and he always put it on the same shaft directly. So to build a generator like Tesla did, I'm not quite experienced enough to do that. I'd be fighting the eddy currents and stuff, so I just found the quickest and easiest solution. Tesla didn't have neodymium magnets. And that makes it so that we can just have two simple coils around here. It's like an axial flux generator, but without 20 coils or 10 coils and 10 magnets. It's just this high power concentrated into a small spot. The faster it goes, the more energy you can produce. And of course, in the vacuum, there's no friction, so your RPMs, you're not limited to the air friction when you're in the vacuum. So the speeds are enormous. This thing, when we shut this thing off, it'll run for 20 minutes, like I was saying in the past, just on centrifugal force because there's no friction. You just take that friction loss that you normally get, and it's no longer a problem. So yeah, simple generator, directly attached to the rotor, perfectly balanced in the vacuum, running in the cryophorus, and you should be able to extract 100% of your heat energy out of your water. Water can store an enormous amount of energy. Even mercury can't store, because it's mass. Even mercury can't store as much energy as water can store per weight. Water can store a lot more energy than mercury, or per volume. I think it's per volume. Would have to double check on that. But yeah, cheap batteries, best solar system on the planet. Just build heat panels. If you build them yourself too, they're extremely cheap. And even if you were only 90% because you built it yourself, you can take up so much more area and you're getting 5 times the solar energy per area. So you could just basically look at any of one of your solar panels or anyone's solar panel out there and just say, okay, what if that was 5 times bigger? What if each one of those panels was 5 times larger? And what if it was cheap to build? And you could store all the energy. That's the hardest part, is to store your solar energy. That's the most expensive part.
I heard yesterday Paul might be presenting.
I think I'll try to start her up now.
Yes.
He's offered. Okay.
Yeah, I hope he does.
I'm gonna actually. I do need to vacuum it out. May as well.
Okay, so you're gonna vacuum the air out first.
We're still getting. I believe we're still getting air out of this tank too, and out of the water itself. Water actually contains a lot of oxygen and other
I hope that
and nitrogen and stuff.
Okay.
So
have any interest in turbines.
I'll plug her in.
I actually put a discussion panel together.
Hey, we just heard that creep. I added these since last time because I took it all apart and I was like, it was blowing in, and that's I think part of the reason it caused the leak. So I glued these on there with the acrylic weld. Acrylic weld is basically as strong as the acrylic because it doesn't glue it, it dissolves it, and then the solvent evaporates and absorbs into the leg stand evenly, and then you've got a strong bond.
You just get one. Okay, for sure.
April started it. Oh,
There
there we go. And theoretically, the RPM will just keep going up and up and up and up because there's no restriction in velocity. So your volts will go up and up and up, and your capacity, the amount of energy you can draw, will go up and up and up. We're mentioning the vacuum. This really I think I gotta. It's a Lexan box, so it's pretty durable.
Yeah, we're not worried, but we're gonna throttle it back.
Yeah.
It's a harmonic with the lubrication and the bearings.
And this wasn't balanced with Tesla's patent. If we could perfect Tesla's balancing pattern, we shouldn't be able to hear anything.
But there's no vibrating.
There's not a lot.
Yeah, so it's very high frequency.
Yeah.
Yeah, so you're up against right now you can't push the lubrication out of the way fast enough in the bearing. That we can hear that. That's the main drag. Yeah. So you don't have a tap on it right now, but what do you think this is?
Well, we were able to check when it cleared up when we were running it, and it was 20,000. About this second. It was about 20,000. And of course, when you can have a certain amount of turned off. Oh yeah.
Oh, no, this,
Oh, okay.
I can tell.
So the nozzle also needs to be tuned as well. So it's not just one issue. Also, the casing is divided in half and it leaks from stage 1 to stage 2. That's a big no-no. That's why this is just going to get better and better and better.
Plus the value we can do it some all the rest.
Yeah.
Yeah, this is the beginning.
This is the beginning.
This good at the beginning. This is why I had to come down and see this thing for myself, because I just said, oh, damn. Aaron, you want me to hold up the flurry and show the flare so you can film that?
And you can just squeeze that, take a picture of anything.
Okay, well, no, I mean just so you can get a film.
And the vacuums are staying the same. We got rid of our leaks, so it should run for a really long time.
Yeah.
Oh yeah, look, our pressure is negative 14 inches of mercury.
Yeah. So the machine's running on the differential between this vacuum and that vacuum. It's a real shame. And the system is maintaining the vacuum while it runs.
Exactly, while it runs.
It's a fluid
not gonna
T-bore running between the negatives,
Right.
right?
Yeah.
15.
That vacuum's going up,
Is it?
isn't it?
It kind of looks like it.
I didn't see it that way.
I don't know if it is for sure, but
Okay.
yeah. this is 26 inches of mercury. At 29, closer to what Tesla's pump achieves, and at high volumes, you'll need a condenser, and because it's in such a high vacuum when that pumps, and the valve of the conduit hooked up to the exhaust of the pump will keep the ambient air from re-entering.
Right.
So this is negative. This is 30 inches of mercury.
Right.
And this is vacuum. Once it gets to zero,
But see, it's past 14 now. It's slowed down to what, 16?
is it? Oh, is it going up? Oh yeah, it's going up.
No, it's going.
Oh, okay, it's going down.
This is higher vacuum.
Yeah, it's higher vacuum. Yeah. I wonder if that perlite made a difference. It doesn't seem like the perlite made a difference.
Well, not that we can see right now.
Not that we can see right now. Yeah. So the more efficient this is, the colder this should be.
Yeah, what's the temperature here?
It's warm.
Yeah.
And the input should be around 170.
You started
Well, that says 202 or so.
Yeah.
Oh, 202, okay.
So, well, even if it's off, I think we're comparing apples and apples with just
Also-
reading both sides. So it's,
Also, Tesla said you should run your load at half the velocity of your incoming particles,
Yeah.
and that extracts the maximum amount of energy. And the more energy you extract, the colder your exhaust is. So at 100% efficient, this should be freezing temperatures. This should be
what?
so cold freezing
Yeah.
temperatures
Yes.
at 100% efficiency.